chapter 9 is a chapter on perimeter and area. And pretty much all perimeter or all area formulas of quadrilaterals come from the combinations of different kinds of triangles. Like if you take apart this triangle and put it together, if I can get it together here. You get a rectangle, right? Can you see it? Right? So basically, the formulas we're going to learn today, just the basic basic formulas for the quadrilaterals and the basic shapes, are all based on cutting and pasting together triangles. And we use what we call the area addition postulate. Remember segment addition and angle addition that said pieces of a segment added together give me the whole segment, pieces of an angle added together give me the whole angle. Well, the area addition postulate says that if you've got pieces of a region and you put them all together, you're going to get the area of the whole region. Okay? So let's look at these area formulas, and hopefully if you think about it as different pieces put together, it'll help you remember what the formulas are. So we start out with just a basic rectangle, okay, which is base times height. That gives you the area. You learned that a long time ago. I'm sure you're fine with it. A parallelogram, if I chop off this piece of a parallelogram and move it over here, I have a rectangle again. So I didn't lose anything. It's still the same area. So the formula, again, base times height. Now, I got to give you a caveat here. Remember, height is always perpendicular to the ground. So it's not, this side here is not height. It's the height straight up and down. Okay? Now, if I took this triangle and do, again, if I split it, I'm going to move it over here, right? And that's one, so it's base times height still, because it's still a rectangle, but you'll notice that it's half of the base. Oops. The base starts here and just goes over to there. So it's half of the base times height. Okay? For a trapezoid, again, you're taking, if I chop off my right angle and move it over here, right triangle, okay, I have base times height, but to get this base, it's B1 plus B2 divided by 2. It's taking the average of the bases. So you take the top of the trapezoid and the bottom of the trapezoid, add them together, divide by 2. That's the average, right? Times height. Okay? For a height, it's, if you take this little triangle here and move it over, and you take this triangle here and move it over, okay, again you have a rectangle. And the rectangle is base times height, but you've just shrunk it, the one side of it in half. Okay, this went the whole length of the shape, but now when we folded it over, we took away half the distance here. So it's 1/2 of D1 times D2, base times height. Okay? And the rhombus works the same way. You're still taking this triangle here, moving it over here, and this triangle and moving it over here. Okay? So again, you're taking the whole D2, but only half of D1. So it's 1/2 times, So it's base times height. Okay? All right, so take a second and see, using those formulas, if you can find the area of these shapes. Okay, so this one is just base times height, and we know that the height has to be perpendicular to the ground, so that makes that height. So 23 times 12, 276 square centimeters. Now this one is a little trickier, but then again we're in honors, that you've got to find the height. Remember, height's from the top of the shape perpendicular to the ground. So you've got to find this by using the Pythagorean theorem. So I did a squared plus b squared equals c squared, and I solved, and I got that b is equal to 9. And then I plugged it into the 1/2 times base times height formula, and I got 54 square inches. Okay? Now, on a rhombus, we know that the formula is 1/2 diagonal 1 times diagonal 2. Okay? And we know the area is 72 square yards. So we set 72 equal to, and we know that this half of the diagonal is 16, so the whole thing is 32. So I do 1/2 times d1, which we don't know because that's this diagonal here, times d2, which is 32. So I get 72 is equal to 16 times d1. I take 72 divided by 16, and I get 4.5. So d1 is 4.5. Okay? So you can solve for missing pieces given but you got to know all but one thing. So again, if you're finding the height, we know the area is, the formula is 1/2 b1 plus b2 times height. Okay, we don't know the height, but we know b1 and b2, and we know the area. So 280 is equal to 1/2, and then 8 plus 20 is 28 times h. So I get 280 is equal to 14h. I take 280 divided by 14, and that gives me 20. So the height is 20. All right? Okay? Now, again, you don't, just because they're variables, you don't do anything different. You still are going to find the area by base times height. So the base is x plus 8. The height is x. So the area is x squared plus 8x. And we can't really solve for x because we don't know what the area is. If we knew what the area was, we could plug it in and solve for x. All right? All right, take a second and see if you can find the area of these shapes. And remember our tricks for 30, 60, 90 triangles. Okay, so to find, we knew that the area formula for the kite was d1, 1/2 d1 times d2. I just had to find the pieces of d1 and d2 that were missing. Actually, d1 was all there because we know that in a kite, the diagonal that connects the equal angles is bisected. So we know if this is 4.1, then this one up here is 4.1. So we just had to use Pythagorean theorem to find this piece and then this piece and then add them together. And that's what gave me the 14.79. And then I just had to plug them in. 1/2 times 8.2, which is the two 4.1s added together, times 14.79. And that gave me 60.64 square units. Okay? Now, again, if we don't know the area of, we can't solve for x, but I can simplify it. So I know that across from the 30 is an x, across from the 60 is the x squared root of 3. So I do 1/2 base times height, which is 1/2 x squared root of 3 times x. X times x is x squared, and then the square root of 3 just comes along for the ride. and the whole thing is times 1/2 or divided by 2. So I can't solve for x at this point, but I can write it like in the simplest form possible. Okay? All right. Okay? All right. I think that's it.